Hello my dear students, welcome back to C level physics. All the best for all senior students for your tomorrow's physics IP exam. So do it well. So in this video I would like to explain how to find time period in the various situations of simple harmonic motion, right? So here we have two methods to adopt. First method, dynamical method, and second one is energy method. So we can use or we can adopt any one of these two methods, right? So in first method, have to follow some steps. Here we have three steps to find time period in various situations of simple harmonic motion, right? So first step, that is to find mean position, that is x equal to 0 at which f net equal to 0, right? Suppose during the oscillation of particle, first of all we have to assign the position, mean position at which net force equal to 0. So at mean position there is no need of restoring force, therefore net force equal to 0. Next, step 2, we have to draw the particle from its mean position through an amount x, then take f net equal to minus kx. So it is pulled aside from its mean position through an amount x to get f net equal to minus kx. Here f net, in the sense it may be restoring force, otherwise there are more than one force, so we can take f net also, that is f net equal to minus kx. So it is pulled aside through a distance of x, so that to apply f net equal to minus kx, right? So here k means one constant related to oscillation, that is k equal to m omega square. So from which omega equal to root k by m, right? So step 3, to take t equal to 2 pi by omega. After knowing omega, angular frequency, one can take t equal to 2 pi by omega, that is 2 pi into 1 by omega means root m by k. So that's how one can determine the time period of simple harmonic motion in the given situation. See the other method, method 2, that's what? Energy method. So we know that during the oscillation of the particle simple harmonically, even though potential as well as kinetic energy changes, its total mechanical energy remains constant through its path at any position or at any instant. So to take step 1, to take total mechanical energy E at any position except at x equal to 0 or x equal to plus or minus A. X equal to 0 means what? Mean position. X equal to plus or minus A means both extreme positions. So except mean position and extreme positions, we can take total mechanical energy at any position except these three positions. Exclude these three positions. So we can take total mechanical energy at any position except all these three positions, right? Now step number 2, as total mechanical energy is constant, if it is differentiated with respect to time, dE by dt must be equal to 0. So from which we can get acceleration. So after taking total mechanical energy, it is to be differentiated with respect to time and is to be equated to 0 to have the value of acceleration, right? So after knowing acceleration, in step number 3, we have to compare this acceleration with that of equation of SHM. What is that equation of SHM? That is A equal to minus omega square into x. So from which we can know the value of omega, angular frequency, that is t equal to, in step number 4, time period t equal to 2 pi by omega. So that's how one can determine the period of oscillation of any simple harmonic motion in any situation, right? Now, as an example, first of all, I want to know the time period, otherwise the period of oscillation of simple pendulum, right? First illustration, simple pendulum, right? So we can take any one of these two methods. I am interested in taking first method. So method 1 is adopted in determining the period of oscillation of simple pendulum, right? Period of oscillation of simple pendulum. Okay. Now what is meant by simple pendulum? It consists of a small bob of mass m which is suspended by means of light inextensible string from the ceiling. Now the bob is made to oscillate on either side of its mean position. Okay. Now I want to know the period of oscillation of that simple pendulum. See, here it is ceiling, from which One bob is suspended from by means of a light inextensible string here. Light inextensible string. Now this is what point of suspension, this is what center of the bob. Now the distance between point of suspension and center of the bob is said to be L effective. L effective, that is L. Length of the simple pendulum. Right, length of the simple pendulum. See, this is what inextensible light string. Inextensible means its length remains same when it is at rest of condition, otherwise when it is in motion. So there is no change in length of that string when it is either at rest or in motion. So there is no extension for the string, right? So that is what inextensible light string. Now it is made to oscillate. What is the mass of this bob here, M? So it is made to oscillate. How it oscillates means when it is pulled aside, it is pulled aside little bit and left to itself. Now it executes oscillations on either side of the mean position. See, here it is mean position, right? This is mean position. Why? Because when it is left to itself, finally it comes to rest at this position. So this is what mean position. Mean position. So first step is over. Mean position. This is what mean position. It is pulled aside. Now what is the second step? It is pulled aside and left to itself to have net force. Now see, this is what mean position. It is pulled aside and left to itself like this. Now what is the angle made by the string with the vertical, otherwise mean position? See here, theta is the angle made by the string with the vertical, with the mean position, otherwise, right? Now see, the weight of the bob is acting downwards, mg, downwards. Now this is what, if it is theta, this one also theta. Now try to resolve weight into two components, two mutual perpendicular components. So this is what mg cos theta, mg cos theta. Now here it is mj sin theta, like mj sin theta. These two perpendicular to each other. So these two perpendicular to each other. So take like this, mj sin theta, mg sin theta. Now see, this is what usual mean position actually. This is what usual mean position here. Now it is displaced like that. See, this is what displacement of the bob. Displacement of the bob like this, x. Here it is x. Now see, x and mg sin theta are directed opposite to each other. Now here it is what tension. Here it is what tension. Now it is length, right? See here, mg cos theta balances tension. Now we left with mg sin theta only. So mg sin theta is unbalanced force. Mg cos theta and tension both balanced each other, right? As per Newton's first law. Now mg sin theta is unbalanced resultant force. Moreover, this is directed towards mean position of the bob. See, mg sin theta directed towards mean position, but displacement is rightwards. Mg sin theta opposite to displacement. So definitely mg sin theta tries to make the bob to get back to its initial position. That's why this mg sin theta behaves or serves as restoring force for the bob, right? So mg sin theta will be the restoring force. Okay, so in second step, that is F net equal to minus kx. What is F net here? F restoring force, that is minus mg sin theta. Mg sin. Now F restoring force, otherwise F net is equal to minus kx. So minus kx equal to minus mg sin theta, right? Minus mg sin theta. So minus minus cancel here. Why it is with the negative sign means restoring force is opposite to displacement. That's why this is what retarding force, in other words. Retarding force. Why? Because it is deviated from its mean position. See, direction motion is this way, but force is opposite to direction motion. That's why this is restoring force, otherwise retarding force also. So that's why we have to consider with the negative sign. Now as per F equal minus kx, that is Fr is replaced by minus kx, that equal minus mg sin theta. Minus minus cancel here. We left with the kx equal to approximately equal to mg sin theta can be written as mg theta. Why? Because for small theta, Sin theta almost equal to theta. Why? Because if it is oscillating with the smaller amplitude, smaller angular amplitude, then no need to consider air friction or air currents, etc. These are dissipative forces which decreases, which affects the period of oscillation. So to avoid that confusion, it is granted to take that theta is very small, means it executing oscillations with the smaller amplitude, thereby theta is very small. So for small theta, sin theta almost equal to theta. Since for small theta, sin theta almost equal to theta, almost equal to tan theta, that equal to sin theta equal tan theta for small theta, almost equal to theta, that is sin theta, otherwise tan theta. Opposite side by hypotenuse. See this triangle, opposite side by hypotenuse, opposite by x side, that is x by l. So in next step, that equal to x by l here. So kx equal to mg into theta means what? X by l. This is what one approximation in solving this sum, that is x by l. X by l. X cancel. So we have k equal to mg by l. Right? Mg by l. Now what is the value of k in general? K equal m omega square. Now compare k with that of m omega square. But k equal to m omega square. But k equal to m omega square. Now what is k here from this relation mg by l? Mg by l. So mm cancel. We left with omega square equal g by l. Implies that omega equal root over g by l. So we have the value of angular frequency. Now step number 3, that is time period equal to 2 pi by omega. Time period equal to 2 pi by omega. That is 2 pi into 1 by omega. 1 by omega means make it reverse, that is inverted. And inverting L by G. Take the reciprocal here. That is T equal to 2 pi omega. 2 pi by divided by omega, that is 2 pi root over L by G. Here L means what? L effective. L stands for L effective. In different situations, we have to consider effective length. In the same way, G means G effective. G stands for G effective. So if there are more than one force, suppose if the problem involved more than one force, then we have to consider net force. In the same way, we have to consider effective acceleration. So that's why G stands for G effective, L stands for L effective also. Right? If at all the distribution of mass varies in a given sum, that is shifted, mass is shifted. If at all given sum, in given sum, mass is shifted either upwards or downwards, then effective length also changes. So that's why in general L stands for effective length, G stands for effective acceleration due to gravity. So what is the expression for time period here? T equal to 2 pi root over L by G. L by G. Suppose in case of seconds pendulum, what do you mean by seconds pendulum? It is a pendulum whose period of oscillation equal to 2 seconds. Is said to be a seconds pendulum. So for example, in seconds pendulum, time period equal to 2 seconds. Now find its length. What is the length of seconds pendulum? Now take this formula. Solution T equal to 2 pi root over L by G. Now on squaring T square equal to 4 pi square L by G. That is, what is the value of time period here for seconds pendulum? 2 seconds. So for each oscillation it takes 2 seconds only. That is 2 square equal to 4 pi square into L by G. So pi square almost equal to G. Pi means 3.14. On squaring almost equal to G. So pi square G cancel. So 2 square 4 cancel. 1 equal to L. That is L equal to 1 meter. That equal to 100 centimeter. 100 centimeter. This is what? So length of the seconds pendulum. 1 meter, otherwise almost equal to 100 centimeter. Right? Now coming to different cases of simple pendulum. Right? Suppose the same simple pendulum is fixed to the ceiling of a car. Otherwise, the simple pendulum is fixed to the ceiling of elevator. Here we have different cases. Elevator is at rest or elevator is accelerating either upwards or retarding downwards. Otherwise, elevator is retarding downwards, retarding upwards, otherwise accelerating downwards. So these kind of situations we can solve the period of oscillations, right? Now, first of all, we have to consider pendulum, simple pendulum in lift, otherwise elevator, right? In the lift, otherwise elevator. So case 1. In case 1, see here, this is what one elevator or lift. To its ceiling, one pendulum is fixed like this, right? Now elevator is at rest, for example. Elevator is at rest. Now what is the force act in this one? Vertically downwards mg, upwards t, right? Now length of the pendulum, simple pendulum is here, right? Now what is the time period here? T naught equal to 2 pi into root over L by G. L remains here. What is the acceleration due to gravity here? G1. So G1. T naught equal to 2 pi into root over L by G. Usual expression for time period, right? So case 2. In the case 2, same elevator is this time accelerating upwards, otherwise retarding downwards. See here, accelerating upwards or retarding downwards. In both one and the same. If acceleration and retardation are same in value, then either accelerating upwards, otherwise retarding downwards, in the sense both one and the same. So both cases are same. Why? Because here acceleration upwards, retarding downwards, in the sense acceleration is upwards only. So both cases are identical, right? So here same pendulum is taken to the ceiling like this, right? Now assign the forces on the bob here. This is bob, mg down, right? See here acceleration is upwards. Now the pendulum is fixed to the accelerating elevator. So we have to consider pseudo force opposite to the acceleration of the elevator to make the Newton's law valid. That is why, see here acceleration is upwards, so therefore you have to include pseudo force ma. What is the mass of bob here? M. What is the acceleration of the elevator? That is the frame attached to elevator is non-inertial frame. So therefore while working from non-inertial frame, we have to include pseudo force apart from real force. See here, what is the real force here? Mg. What is the real force? Mg. What is the pseudo force? Fictitious force, that is Ma. So it is to be taken opposite to the direction of acceleration of the frame, right? See, acceleration is upwards, therefore it is to be included downwards to the real force. So Mg plus Ma. So if Ma is neglected, Ma is eliminated to get resultant acceleration. That is, see here, downwards G plus A. G plus A is the net acceleration. So G effective equal to G plus A. Now in the expression T equal to 2 pi into root over L by G effective. That is 2 pi into root over L by G effective means what here? G plus A. See, why? Because apart from real force Mg, a pseudo force Ma also included downwards. So therefore net force downwards equal to m of G plus A implies that acceleration equal to G plus A. So it is not G, that is G plus A. So time period, is it increasing or decreasing? See, denominator increases when compared to previous value. When the elevator is at rest, this is T naught equal to 2 pi root L by G1, but here it G plus A, denominator increases, implies that time period decreases. So is less than T naught, right? So is less than T naught. Next, case 3. Suppose elevator is accelerating downwards, otherwise retarding upwards. So both cases one and the same. Acceleration downwards. Here retarding upwards means Deceleration upwards implies that acceleration is downwards. So both cases are same. So in both cases, same formula will be valid here. That is, here see, elevator. This is what? Pendulum. Now acceleration is downwards, right? So assign the forces here. M is the mass of the pendulum bob, that is mj downwards. See, the acceleration of frame, that is downwards. That is, as elevator is accelerating downwards, it is to be taken, a frame attached to elevator becomes non-inertial frame, which is accelerating downwards. So to make Newton's laws valid, the pseudo force is to be taken opposite to the direction of acceleration. That is, acceleration downwards in the sense, pseudo force is upwards. That is, ma is upwards. Pseudo force is upwards. Pseudo force is upwards, right? So what is net force here? Net force equal to mj minus ma. F net equal to mj minus ma. That is m of g minus a. See, mass multiplied by a resultant acceleration, g minus a. So therefore a is upwards, g is downwards, implies that g effective equal to g minus a. See, g minus a. Therefore t equal to 2 pi into root over L by g effective, that is equal to 2 pi into root over L by g effective means g minus a. G minus. See here, in usual formula t naught equal to 2 pi into root over L by g, but here it is 2 pi into root over L minus g minus a. Denominator decreases, in the sense the value of t increases. So t is greater than t naught. T is greater than t naught. Right? Next. Right. So in the same case, one note point here. Suppose in this situation, the cable which carries the elevator breaks here. So elevator breaks, in a sense it becomes freely falling body. So freely falling in the sense, whenever cable breaks, so it moves down with an acceleration a equal to g. So when it moves down with an acceleration a equal to g, right? So this becomes a freely falling body. Implies that, so this expression implies that t equal to, in case of acceleration downwards, what is the valid expression? T equal to 2 pi into root over L by g minus a. G minus a. That is 2 pi into root over L by g minus a means again g, something by 0, that is infinite, tends to infinite. So time period equal to infinite, in the sense it doesn't oscillate. Implies that pendulum doesn't oscillate. So time period equal to infinite, in the sense no oscillation. Frequency equal to doesn't oscillate, that is n equal to what? N equal to 1 by t, that is 1 by infinity, that is 0. So number of oscillations made per each second equal to 0, means it doesn't oscillate. So whenever a simple pendulum is fixed to the freely falling lift, to the roof of the freely falling lift, it is not going to oscillate. So frequency equal to 0, time period is infinite. So that is the meaning. Okay. Now we can have few more cases. In case of simple pendulum, suppose the same simple pendulum is fixed to the ceiling of an accelerating car. When car is accelerating, what is the period of oscillation of simple pendulum? Right, that is the situation. Again, we have two sub cases. If car is accelerating in a straight line on the horizontal road. One more case, if the car is accelerating, otherwise taking a turn near the on the circular unbanked road, right? Next one, case 4. Suppose one car is going to one car is accelerating like this, right? accelerating on level road. What is the acceleration of car here? A. Now this is what vertical here. One pendulum is going to oscillate, which is fixed to the ceiling of the vehicle. Alright. Now see, why it is pulled away from the mean position means it is acted upon by pseudo force. See here, car is going to accelerate on level road. So therefore, it is acted upon by MA, pseudo force. Pseudo force. See, a frame attached to accelerating car becomes non-inertial. So pendulum is fixed to the non-inertial frame. Therefore, it is while working from non-inertial frame, we have to include pseudo force apart from real force. What is the real force? Mg down. Mg down. Right. Mg down. Ma opposite to the acceleration. Right. Opposite to the direction of acceleration. We have to consider pseudo force to make the Newton's law valid. Right. So here it is. We have to. Here it is Mg. Here it is Ma. Both are perpendicular to each other. Of course, here tension also will be there. Right. So what is net force here? See here, Mg down, Ma leftwards. Now this is what resultant force. So Fr equal root over Mg square plus Ma square. Otherwise, if M is neglected, Ma is excluded in both terms. So same can be written as G and A. Now this is what G effective. G resultant acceleration. G effective in the sense G resultant. So what is the resultant acceleration here? Otherwise, effective acceleration. So G effective equal root over G square plus A square from Pythagoras principle. Otherwise, from parallelogram law of addition of vectors. Root over G square plus A square equal G effective. G square plus A square. Now the formula. What is the formula? T equal 2 pi into root over L by G effective. So L remains same. When it is either at rest or in motion, in oscillation, L remains same here. So therefore 2 pi root over L by G effective, that is 2 pi into root over L by G effective in the sense, again root over G square plus A square, G square plus A square. This is the valid expression. 2 pi root over L by root G square plus A square. Again, T is divided from usual T naught, right? Next case, the same car is taking a turn on the circular unbanked road. See, case number 5 is what on circular road like this, circular road, right? Here one car is going to take one turn on the unbanked road. Right. This is a top view of the car. Right. Now it is subjected to centripetal force. Implies that it is acted upon by Fc. Relevantly, it possesses some centripetal acceleration is. Right. Now what is the radius of the center of the circular track here? Let it be R. Right. See, if any particle to go around the circle, it is acted upon by some resultant force. What is the resultant force? Centripetal force. What is the direction of that resultant force? Always towards the center of the circle. So as centripetal force is towards the center, centripetal acceleration also towards the center. Right? So again, here one pendulum is fixed to the ceiling of this car, which is taking turn on the circular unbanked road. Now definitely that pendulum bob experiences some pseudo force opposite to the acceleration of the vehicle. See, what is the acceleration? What is the direction of acceleration of the vehicle here? Towards the center. So therefore, if it is seen, the same situation, if it is seen horizontally above the ground, that is close to the ground, see, we can see the oscillation of pendulum like this. When it is seen horizontally, this is what top view. When it is seen horizontally, a little bit above the surface of the ground, then we can see the oscillation of pendulum like this. See, this is what mean position. Now see, AC is directed towards center. Definitely, it is pulled away from the center of the circular path. Why? Because pseudo force is acting opposite to the acceleration of the car. So therefore, see, this is what it moving. it is taking a turn with constant speed v, right? So here pendulum is pulled away from the center of the circle because of pseudo force, right? It is acted upon by pseudo force, MA, pseudo force, right? MJ down again. So MA horizontally rightwards, MJ vertically downwards. So again we have two forces. This is real force or true force. This is what? Pseudo force. Now what is the resultant here? See, this is what MA pseudo force. This is what real force MJ. If MA is excluded, if you want to write A and G only, so it is reduced to A and G like this. Now this is what? G effective. G effective. Otherwise resultant acceleration. So resultant acceleration, otherwise G effective equal root over A square plus J square. So again G effective equal to same formula, here also same, root over G square plus A square 4. Now what is A here? It is AC, so therefore this is also AC, centripetal acceleration. Otherwise centrifugal also while working from non-inertial frame, that is AC. Yes, a small modification, everything is working here and there, same only. Concept will be same in both cases, but a small variation. Here it is usual acceleration, linear acceleration, but here it is centripetal acceleration or centrifugal acceleration also. It depends upon frame. So therefore T equal to 2 pi root over L by G effective. That equal 2 pi root over L by G effective means again root over G square plus AC square. Not A but AC square. Yes, that only the modification. That only the small variation. Here it is A, here it is AC square. Everything is same. So T equal to 2 pi into root over L by G square plus AC square. Now what is AC? AC means we have three obligations. Either V square by R, otherwise V omega, otherwise R omega. We have three expressions for centripetal or normal or radial acceleration. So it has three names for AC. One is centripetal acceleration, another one is normal acceleration, other one is radial acceleration. So here three forms for AC, that is either V square by R, otherwise V omega, otherwise R omega square. Here R means radius of the circular path, V means speed of the vehicle, omega means angular frequency, R means radius of the circular track, right? So that's how one can find time period in various situations. We have one more situation, that is the same vehicle is accelerating down the inclined plane, for example. Situation number, otherwise case number 6. Case number 6. See, last one. Case number 6. Here one inclined plane is there on which a car is accelerating down the inclined plane. To the ceiling of that car, one pendulum is fixed. Now how it oscillates? What is the period of oscillation of that pendulum as car is going to accelerate down the inclined plane? See, this is what inclined plane like this. Right here, one car is going to accelerate down the inclined plane. What is the angle of inclination of the inclined plane? Theta. Right here, see, this is what normal drawn to the surface of the inclined plane. Now this is the pendulum. This is the pendulum, right? Now its weight is acting vertically downwards like this, mg. Now here it is, take two perpendiculars. See, this is what a perpendicular drawn to the, this is the normal drawn to the plane of the inclined. This is what one more perpendicular. These two opposite perpendicular to each other. Now here it is theta, it is 90 degrees, it is 90 minus theta, here it is theta. So theta, see here one right angle triangle is formed. So theta here 90 here 90 minus theta, here it is theta. Right? Now try to resolve weight of the bob into two perpendicular components. One is mg cos theta, that is normal to the surface of the incline. Another one is mg sin theta, mg sin theta, that is down the inclined plane. So this is resolved into two components, two mutually perpendicular components. See, this is the adjacent side. If I close this side like this, Now this becomes adjacent. Therefore, if it is mg along hypotenuse, so along adjacent it becomes mg cos. Why? Because mg cos side equal adjacent side by hypotenuse. That is implies that adjacent side is equal to mg cos. This is what opposite side. So these two sides one and the same. So definitely this will be the mg sin theta, that only represented here. So mg sin theta, mg cos. So mg sin theta here means here also mg sin, right? Now see, this time also car is accelerating. Now a frame attached to accelerating car becomes non-inertial. So while working from non-inertial frame, have to include pseudo force apart from real force. This is what real force, real. This is what real force. See, what is the acceleration here? G sin theta. If m is excluded, that is mg sin theta equal ma, cancel, we have g sin theta. So what is the acceleration of this frame down the plane means g sin theta, right? So opposite to acceleration of the frame, we have to include one pseudo force also. That is, what is the mass of the pendulum of m? So m into acceleration of the frame. What is the acceleration of the frame down the plane? That is g sin theta. So m into g sin theta. ma, in fact ma that equal to mg sin theta. This is what pseudo force. Pseudo force opposite to the acceleration of the frame, otherwise called. Right? So these two are components of mg. If these two components are excluded, we have to consider mg only. So that's why here we have only two forces. If these two are excluded, why? Because these are nothing but the components of mg only. So exclude these two. Now mg, one real force, m otherwise mg sin theta, one pseudo force, like this. See, this is what mg sin theta. This is what mg. Now what is the angle between these two? See, theta plus 90. Here it is 90 degrees. See, what is angle between these two lines? 90 degrees. 90. Okay, 90 degrees. So what is the angle between these two? These two, that is, these two vectors are inclined at an angle theta plus 90. That is 90 plus theta. 90 plus theta is the angle between real force mg and pseudo force mg sin theta. Right? If m is excluded here. If acceleration is only written, then exclude m, that is same can be reduced like this. So g sin theta, it is g1. Now what is the angle? 90 plus theta. So these two are parent vectors. Now what is the resultant vector? That is g effective. G effective. See, try to close parallelogram. Parallel to this vector one side, parallel to this vector one more side. So now resultant is the diagonal. So this is what g effective. G effective. Now how to get the g effective? How to get g effective? So making use of parallelogram of law of addition of vectors, that is r equal root over p square plus q square plus 2pq cos theta. So r means g effective. G effective equal, otherwise we know that r equal root over p square plus q square plus 2pq cos theta. Right? P square plus q square plus 2pq cos theta. That is r means what? G effective. G effective equal root over p square means g square. Q square means g sin theta whole square. Sin theta whole square plus 2pq. Pq. 2g into g sin theta into cos theta. Cos theta means what? 90 plus theta. Theta is the angle between p bar and q bar, but here p bar is g bar, q bar is g sin theta bar. That's why what is the angle between these two? Theta means 90 plus theta. 90 plus theta. Right. So g effective equal root over g square plus g square sin square theta plus, that is cos 90 plus theta, that is minus sin theta. Cos 90 plus theta minus of plus minus sin theta. Sin square theta 2g square into sin theta into sin theta, sin square theta. That is sin square g square sin square theta minus 2g square sin square theta, that is minus g square sin square theta, that is root over g square g square minus g square sin square theta, that is g square is common and kept outside, it becomes g root over 1 minus sine square theta, that is g into root 1 minus sine square theta, that is cos theta, g cos theta, g cos. So what is the g effective in this case? G effective equal to g cos theta. Now take the same value in the formula of t equal to 2 pi into root over L by g effective. That is t equal to 2 pi into root over L by g effective means what? G cos theta. G cos theta. So g cos. So in this case, when car is accelerating down the inclined plane of inclination theta with the length of the pendulum as L, then what is the period of oscillation of the pendulum here? T equal to 2 pi into root over L by g cos theta. Okay friends, thanks for watching. See you in the next video. Bye.